plus 3 plus 4 plus dot 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 dot. This is a series. So this is a sequence, and this is a series. Of course, arithmetic series is one that you're going to have the same difference. So for example, you can have a 2 plus 4 plus 6 plus 8 plus 10. So we're adding 2 each time. Or we can subtract 2. You can have 2 plus 0 minus 2 minus 4 minus 6 minus dot 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 dot. So this is known as arithmetic series because we're adding or subtracting to get the next term, and we're adding all the terms together. In geometric series, obviously we're going to multiply. Let's say you had a 2, 4, 8, 16, dot dot dot. That's a geometric sequence. So if you go 2 plus 4 plus 8 plus 16, okay, plus dot dot dot, that's a geometric series. So the only difference between series and a sequence is in a series we're going to add them all together. Okay, so let's come up with some formulas to add up. So let me clear this one. What we're going to do is we're going to add up a sum. We'll call that sum of the series. It's going to be a sub 1 plus a sub 2 plus a sub 3 plus dot 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 all the way to some a sub n. Well, instead of writing it like this, we know that every one of these terms can be written as a sub 1. So this is going to be, sum is going to be a sub 1 plus, instead of writing that out, we can write that as a sub 1 plus 2 minus 1 times the difference, because that's how we find any particular term, plus a sub 1 plus 3 minus 1 times the difference. So the next term will be a sub 1 plus 4 minus 1 times the difference. Okay, so and so on and so forth all the way to the end. It's going to be a sub 1 plus n minus 1 times the difference, and that's going to be the last term. Okay, if we clean this up a little bit, this is going to become a sub 1 plus, that's going to be a sub 1 plus a difference. So a sub 1 plus a difference. And then this is going to be a sub 1 plus 2 differences. And then plus a sub 1 times a sub 1 plus 3 differences. And then plus dot 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 dot. And this is going to be a sub 1 plus n minus 1 difference. Okay, so we have to add all those up. Well, how can we add them all up really fast? Because if we come up with a formula, that would be great. So let me rewrite this formula as s is equal to a sub 1 plus a sub 1 plus a difference plus a sub 1 plus 2 differences, and plus I'm going to skip all the other terms and go to the end, and then it's going to be a sub 1 plus n minus 1 difference. Okay, and then I'm going to rewrite the same thing, except I'm going to go backwards. So it's going to be a sub 1 plus n minus 1 times difference, and then of course the one before that would be over here, would be a sub 1 plus n minus 2 differences, and then plus dot 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 all the way to the very first term, which will be a sub 1. And then if we add these columns, the left side, I'm going to have 2 sums. And then when I add this and this together, I am going to get 2 a sub 1s plus n minus 1 difference. Okay, and then when I add this and this together, I'm going to get another 2 a sub 1s, because I got one here and one there. When I add this plus n minus 2 differences, I'm going to get n minus 1 differences. Okay, and then if I add the last ones together, which is going to give me again plus dot 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 dot, okay, n and I'm going to get 2a sub 1s plus n, okay, minus 1 difference. It looks like every single thing is same. How many of them do I have? Well, when you add them all together right here, I have n of those. So therefore, I can rewrite this. So let me erase some of this stuff real quick here. In the top, I can rewrite that, and I'm almost done with this formula. So I can rewrite this as 2s is equal to n, all that times 2a sub 1 plus n minus 1 difference. And then of course when I divide both sides by 2, I'm going to get my sum formula, which is n over 2, all that times 2a sub 1 plus n minus 1 difference. And that's it. That is my sum formula for arithmetic series. Okay? Alright. So that's done. Let's go to geometric series. Alright, in a geometric series, I'm going to have sum is equal to a sub 1 plus the next term is going to be a sub 1 times some r plus the next term is going to be a sub 1 times r times another r, because I got to multiply the previous one by an r, so a sub 1 times r to the second plus one more a sub 1 r to the third plus dot 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 dot. The last one's going to be a sub 1 times r to the n minus 1. Okay, and then what I'm going to do is I'm going to rewrite this, except this time I'm going to multiply everything by r. Okay, so that's going to be a sub 1 times r, and this one's going to be a negative r. I'm going to multiply by negative r. Okay, so when I multiply that, I'm going to get negative a sub 1 times r. When I multiply this by negative r, I'm going to get another negative. So let me clean that out here. Another negative a sub 1 r squared. When I multiply this by negative r, I'm going to get negative a sub 1 r cubed plus dot 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 dot, or minus dot 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 dot. Okay, and then the last one, I multiply that by negative r. I'm going to get a sub 1 times r to the n, because that r times r to the n minus 1 is going to give me r to the n. Now, if you notice, this and this are exact opposite, so when I add them, they're going to cancel out. So let's add this side. I'm going to get s minus r times s, and this is going to cancel out, and of course this and this are going to cancel out, and that exact opposite is going to cancel out, and of course this is going to cancel out with the one before that, and what's just left is this here and that right there, which is a sub 1 minus a sub 1 r to the n. And when I factor out an s, I'm going to get 1 minus r in the parentheses. Here, when I factor out an a sub 1, I'm going to get 1 minus r to the n. And then when I divide by 1 minus r, I'm going to get my sum formula is a sub 1, 1 minus r to the n. All that over 1 minus r. And this is geometric series. So this is the formula for sum of a geometric series. Now we also have one more formula we need to worry about. Infinite geometric series, where let's say r, absolute value of r is less than 1, meaning I can have r is equal to 1/2, and I could have r is equal to negative 3/4. Anytime this is less than 1, absolute value of that is less than 1, okay, then what happens is when n goes to infinity, since this is a fraction, okay, the r is a fraction, and when you raise a fraction like 1/2 to, let's say, 10,000, this one gets really close to 0, okay, because the bottom number is going to get big. So this formula here now, as long as the absolute value of r is less than 1, this formula now becomes s to the infinity. You can actually add infinite number of terms, is equal to a sub 1 all that over 1 minus r. And this is an infinite geometric series formula. Okay, those are all the formulas we need to know. So let me restate all the formulas. So for arithmetic series, we have a formula. Sum is equal to n over 2, all that times 2 times a sub 1 plus n minus 1 times the difference. Okay, and then for a geometric series, we have s is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. Okay, and then we have infinite geometric series. Okay, s to the infinity is a sub 1 all that over 1 minus r. Now there's also one more formula I can show you, and this is, you can use this formula if you know the difference, but sometimes you don't know the difference. So let's go find out what the other formula is. If you really break this up, that's really a sub 1 plus a sub 1 plus n minus 1 times difference, because 2a sub 1s is going to give me this. And this, from last night's homework, that's your a sub n. So you can rewrite this formula as n over 2, all that times a sub 1 plus a sub n, meaning this is the first term and this is the last term. So if you know the first and the last term, you can just jump to this formula. But if you know the difference, you have to use this formula right there. Okay, so let's do some problems. Okay, so let's go to 25. In 25, they give us a summation notation. K is equal to 1 through 15. And they give us 11 minus 2k. Alright, so what this really means is this is summation notation. This is a short way of writing out a series. So what they want you to do is they want you to plug in 1 for k. So that's going to give me 11 minus 2 times 1. Okay, and then they want you to add to that when you plug in 2. So it'll be 11 minus 2 times 2. And then plus, they want you to add to that 11 minus 2 times 3. So on and so forth. We keep going, okay, until we hit the very last term, which is going to give us, okay, 11 minus 2 times 15, and because that's the end right there. So this is the start, okay, and this is the end. So when you add them all up, I haven't finished writing all these out. I don't have to, but I'll show you a shortcut. That's why I didn't do that. So this is really 11 minus 2, which is a 9. And this is really 11 minus 4, okay, and that is going to give me a 7. And this is 11 minus 6, which is going to give me 5. As you can see, it's going down by 2, so the next one is going to be 3. Next one's going to be 1, and then next one's going to be negative 1, so on and so forth, all the way until we get to the last one, which is going to be plus 11 minus 30. And what's my 11 minus 30? It's going to give me, okay, 19. So this is negative 19. Okay. Now you could do it that way, you can add them all up, or we can use the summation formula, because right now we know that is my first term, and we know my difference is equal to 2, and I know my n is equal to 15. Or I can also do it with using the last term. So let's just do it the old-fashioned way first. So that means sum is equal to n over 2, which is 15 over 2, all that times 2 times a sub 1, which is 9, minus n minus 1, that means that's 15, okay, minus 1, times the difference, which happens to be 2. So this is 15 over 2, all that times 18, and this is 14 times 2, which is 28. And that's going to be 15 over 2, all that times negative 10, and of course that reduces to negative 5. Okay, and that's going to give us negative 5, negative 75. And that's the sum of this series right here. Now I didn't have to write out all the terms, but I just need to know what the first term was, what the difference was, what n was. But I can also go the other way. If I know my first term, I know my last term, which is negative 19, I can use this formula, s is equal to n over 2, all that times the first plus the last, okay, which is going to give me 15 over 2. The first is 9 minus the last, which is, plus 19, which is the last, which is 15 over 2 times negative 10, which is the same thing as right there, which is going to give me negative 75. Okay, so sometimes this formula is easy to use because if you know the first and the last term, and if you don't have to if you can't find the last term, then you can just use this formula. Okay, that's the infinite geometric series. So let's do another one. Okay, this time let's do number 30, which is a 4 plus 6 plus 8 plus 10, and they say dot 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 n is equal to 10. Now they don't give us a last term, so we have no choice but to use the first formula. S is equal to n over 2, all that times 2 times a sub 1 plus n minus 1 times difference. So let's plug in everything we know. We know n is to be 10, so it'll be 10 over 2. All that times 2 times a sub 1, and that's my a sub 1, which is 4, plus n minus 1, which is 10 minus 1, and times the difference. So it looks like the difference is I'm going up by 2. So that'll be 2. Okay, if we clean this up, this is going to give me 5, this is going to give me 8, and this is going to give me 9 times 2, which is 18. Okay, so we're just going to have 5 times when you add the 18 plus 8, you're going to end up getting 26. Okay, 5 times 26 is 125 plus 130. Okay, that's the sum of that series. Okay, let's go to the next problem. Let's go to 31. Okay, in this one they say k is equal to 1 to 7. That means we're going to start at k is equal to 1 and then go to 7. So negative 3 to the k minus 1 is my formula. Of course, if we do it the long way, the first number we're going to plug in is, for k, is 1. So it'll be negative 3 to 1 minus 1. Plus the second number we're going to plug in is negative 3 to the 2 minus 1. And then plus negative 3 to 3 minus 1. And plus negative 3 to the 4 minus 1. Plus negative 3 to the 5 minus 1. Plus negative 3 to the 6 minus 1. And then plus negative 3 to the 7 minus 1. But that will be doing it the long way. Okay? So this first one is negative 3 to the 0 power plus negative 3 to the first plus negative 3 to the second plus negative 3 to the third plus negative 3 to the fourth plus negative 3 to the fifth, and the last one's going to be negative 3 to the sixth. Okay, we can work it all out, or we can use the summation formula. Summation formula says S is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. So, we know the first term. We found that. That's negative 1 to the 0, which is really 1. So this turns out to be 1. And we know the ratio. The ratio is right there, negative 3. That's my ratio right there. Okay? So because I'm multiplying each time by negative 3. Okay? So my ratio is negative 3. So I can plug it in. So I have a 1 times 1 times a negative 3. And how many terms am I adding? 7. So to the 7, all that over 1 minus the ratio, which is negative 3. So two negatives become positive. So I have a 1 minus 3 to the 7, which is going to give me negative. So 3 raised to the 7th power, which is 2187. Okay, all that over 4. Of course, 2 negatives is positive, so we're going to add 1 to that. And then we're going to divide that by 4. And the answer turns out to be 547. Alright. So that's a geometric series. So let's say they wrote this out the long way, and let's do number 36. Let's say you have a 3 plus 6 plus 12 plus 24, and they plus dot 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 dot, and they want you to add 8 terms. So we know what a sub 1 is. That's my first term. So what about my ratio? How do you find the ratio? To find the ratio, you take any term and divide by the previous one. So 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. It will always be the same. So that means 6 divided by 3, which is 2. So 2 is my ratio. So that's all I need. I need the first term, I need the ratio, I can find the sum. Well, I need the n, so I have that too. So the sum is equal to, because we're adding up 8 terms, s sub 8, if you want to write that down, that's fine. Okay, is a sub 1 times 1 minus r to the n, all that over 1 minus r. That's my formula. So that means 3 times 1 minus 2, because that's my ratio, to the power of 8. Okay, all that's going to be over 1 minus the ratio, which is 2. Okay, to clean this up, I have a 3, and then 2 to the 8th, 2 raised to the 8th power is 256. So I have a 1 minus 256, all that over negative 1. Okay, so now this is going to give me 3 times negative 255, all that over negative 1. So 2 negatives become positive. So we just have to multiply 255 times 3, and that will give us a total of 765, and that's my final answer. Okay. Okay, and that is a sub 1 is equal to 1, and they tell us r is equal to 4, so the ratio is 4, and they tell us the sum of this geometric series is equal to 341. And they want us to find, okay, and how many terms did it take to get the sum of 341. So of course we're going to use this formula. S is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. And plug in everything that we know. We know the end result, which is 341. So that implies my 341 is equal to, we know the first term, which is 1, and 1 minus r, and the r happens to be 4 to the power of n, all that over 1 minus r, which is 4. Okay, let's clean this up a little bit and solve for n. So this is going to be 341 is equal to 1 minus 4 to the n, because it's just 1, all that over negative 3. So we're going to multiply 341 and times 3, and so it'll be negative 1023 is equal to 1 minus 4 to the n. Alright, then we'll take the 1 over to the other side. It's going to be negative 1024 is equal to negative 4 to the n. Now, of course, 2 negatives become positive. So I have 1024 is equal to 4 to the n. And I need to solve for n. So how do I solve for n when the n is in the exponent? That's where we get the logarithms. So we're going to ln both sides. ln of 1024 is equal to ln of 4 to the n. Well, the power rule tells us, okay, we can bring that n to the front. So ln of 1024 is equal to n times ln of 4. So to find n, we just have to divide both sides by ln of 4. So ln n is equal to ln of 1024 divided by ln of 4. Okay, and we'll find that. So we're going to go ln of 1024, and then we're going to divide that by ln 4. Okay, hit enter, and it turns out to be 5. So it took us 5 terms to get the sum of 341. Alright, so the lesson is, the lecture is long, but the lesson itself is not that long. So let's go to 39. In 39, they want us to tell us if the geometric series converges or diverges. So we have a 32 over 243 plus 16 over 81 plus 8 over 27 plus 4 over 9. And they want to know if you can add them all up. Converges means you can add all these up. Diverges means we can't add them up. Well, how do we find out? But as long as the absolute value of the ratio is less than 1, it converges. Okay? That means we can add them up. Otherwise, we can't add them up. Okay? Because infinity is a long ways to go to add up everything. So how do you find the ratio? The ratio is nothing more than any term. So let's take the smallest one. Okay? 4 over 9. And we're going to divide that by the previous term, which is 8 over 27. Okay, when you clean this up, if this is less than 1, then we can add them up. If not, then we can't. So it'll be 4 over 9 multiplied by 27 over 8, because we're going to flip the fractions. 9 will reduce that into a 3, and then 4 will reduce this into a 2. Okay, so this becomes 3 over 2, and that is bigger than 1. Okay, absolute value of that is bigger than 1. So we say we can't add these up, therefore it diverges. Okay. Now if we can, if its ratio is less than 1, if this turned out to be instead of 3 over 2, it's like 2 over 3, then we can add them up and we can say it's a convergence. But it's not, so it diverges. Alright, let's go ahead and find something that we can add up. Okay, this is 42. Just have last two problems to explain. So I is going from 1 to infinity. That means we're going to go on forever and ever. 3 times 3 to the I minus 1. Okay, so we have to add all these up all the way to infinity. So we don't need to do that. We have a formula. And the formula says s to the infinity is nothing more than a sub 1 all that over 1 minus r. So all we need to know is what a sub 1 is. I need to know what r is. Then I can add them up without having to write everything out. Well, this is going to be my r. Okay, because that's the, if you notice, this looks a lot like a sub n is equal to a sub 1 times r to the n minus 1. Okay, so that's my r, and that's my a sub 1. So my a sub 1 is 3. Okay, and my r is 3 also. And that is going to give us 3 over negative 2, which is negative 3 over 2. So if you keep going forever and ever and add all these up, okay, you're going to get negative 3 over 2. Alright, that was easy. So these are actually easy. So let's go to the last one. Okay, 46. So 5.6 plus 1.16 plus 0.232 plus 0.0464 plus dot 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 dot. Okay, they want you to add them all up. You're going forever and ever. So first of all, we know that's a sub 1, and we need to know what the ratio is. Ratio is any number divided by the previous one. So let's take that one, 1.16, and divide that by 5.6. Okay, and that is my ratio. Okay, so my formula is s to the infinity is a sub 1 over 1 minus r. So this is b 5.6. All that over 1 minus the ratio. And let's go ahead and divide that out. So it would be not point. It would be 1.16. Divide that by 5.6. And that gives us 0.207. Alright, so I have 5.6 on the top. I have a 1 minus 0.2071, and I get at the bottom I get 0.7929. So when we divide 5.6, divide that by 0.7929, okay, and we're going to end up getting 7.063. Okay, there it is. If you were to add all these up, it's going to get very